Okay, so let's talk about entropy. Um, in general, what we can say is that entropy is the measure of impurity in the data. So, what is the impurity? We'll see. Um, the formula is that, for example, we want to find the entropy of this column y in the data. So, E of y is equal to, we would sum the this product p of j into log base 2 of p of j probability. So, what's this J and what's P? In the data that we'll see in the next slide, we have the this column Y, which has possible values E for excellent, G for good, A for average, B for below average, and F for fail. So this column y can take values from this set. So this is the possible values of j, and the product would be the probability. For example, if I take j is equal to excellent, so I'll check the probability of value excellent in the data, and then multiply it with the log of that probability. So that's the formula how we calculate entropy. So let's calculate the entropy for some data set. So here we have this data set where we have this green column CS201 is the course code. I let it, and this is the label of the data. So I can call it the column Y, and then I have three more columns, or in fact four more columns, whereas the three yellow columns are of an interest here. So CS118 is another course code, CS217 182 are the course code. So I can call them X1, x2, and then x3. So if I want to calculate the entropy of this column y, I want to see what essentially I want to see is that I want to see if this data is pure, that is, if this data has the same value throughout, or there are some different values. So I can see clearly that I have two e's, one g and two f. So there is some impurity in this data, and I want to measure this entropy, measure this impurity, and the and for that the measure is entropy. So the formula, let me rewrite it here. E of y is equal to negative of sum of j, all the possible values, and I'll take the probability of each value and multiply it with the log base 2 of probability of that value. So in this data, what I have is, or if you want to see how I would calculate, is that I would take negative of, now for j is equal to excellent, I have two j is equal to excellent, and I have two excellent values out of 5. So the probability of having an excellent in the CS201 column is 2 by 5. Then I multiply it with log base 2 of 2 over 5. Then this is the first product. Then the second value is good, right? This is good. So this is only one value out of 5. So I would add 1 over 5 multiplied by log base 2 of 1 over 5. Then I have two f values. So I would say 2 of over 5 is the probability of having an f value in the column y into log base 2 of 2 over 5. So this is the entropy formula for column y. Now what I would do is that if I solve this value, what I have is that I have minus 0.53, minus 0.464, minus 0.53. So these are the values. Then if I sum them up, it would be 1.53. So it clearly, the data was impure here. There were different values in the column. So it's 1.53, and which is not equal to 0. Had I had this same value in the entire column, then the entropy would have been 0. But there are different values in the column, so the entropy is something, and the measure is 1.53. So this is how we calculate entropy. I hope it's clear now. And in the next video, we'll talk about the entropy that is conditional to this column CS118, 217, and EE182.